In the last class, we have seen the basic signal operations such as time shifting and time scaling. And also we have seen a few problems related with that. Okay, now in this class, again, we'll continue that. Okay, now first we'll see the examples with the discrete signal. In the last class, we have seen the example with the continuous time signal. Now, okay, first we'll see the problems with the discrete time signal. Okay, for a given discrete time signal, okay, for the discrete signal shown below, for the discrete signal given below, this is the given signal x of n. For this signal, we have to calculate what is x of n minus 4. Okay, that is simply the time shifting, and again x of 3 minus n, time shifting, as well as the times scaling, time reversal. Okay, time reversal also is there, shifting is also there. Here x of n multiplied with the signal, standard signal, that is u of 3 minus n. We know what is u of n. From that we have to calculate what is u of 3 minus n, then again multiply with x of n. Then shifted version of x of n, and then it has to be multiplied with the impulse, discrete impulse, that to the impulse present at n is equal to 2. And again this mathematical operation 1 by 2 x of n plus 1 by 2 minus 1 power n x of n, and then x of 3n plus 1, and then x of n minus 1 whole square. Again, if you see this problem x of 3n plus 1, here we are applying the scaling operation. Okay, we are applying the scaling in the discrete domain. Okay. So now we'll see one by one. First, we have to calculate what is x of n minus 4. Again, it is very simple. When it is x of n minus 4, what is the meaning? N minus 4 is equal to 0, then that means n is equal to 4. Okay, so n is positive, then that means this is shifted towards right side. Okay, so the entire diagram has to be shifted towards right side by 4 units. Then the original diagram, it is starting with the minus 4. Now it will start at 0. Okay, then minus 3 will start at 1. So like that, entire diagram will be shifted by 4 units towards right side. Okay, so you have to shift the entire diagram by 4 units towards right side. Okay, then once if you shift that, okay, then your answer will be like this. For example, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so in the beginning you are getting this value, and again this is minus 1 by 2, and again all are 1, finally this is 1 by 2. Okay, so this is the answer, n, and this is x of n minus 4. That means what? The original diagram will be shifted by 4 units. Once if you shift by 4 units, then it will start at 0, and then it will end at 0, because initially it was ending with 3. Now 3 plus 4 is 7. Now it will end at 7. So again, all the amplitude remains same. See, here amplitude is minus 1, here minus 1 by 2, here 1 by 2, 1, 1, 1, and again this is 1 by 2. Again, there is no change in the amplitude, only we are giving the change only in the time. Okay, so only time shifting is there. Okay, time shift towards right hand side by 4 unit. Okay, so the next question is the next operation is x of 3 minus n. Okay, if you see here shifting is also there, and also time reversal is also there, because n is negative, that means time reversal is there. Again, you can modify this like this. Okay, minus n plus 3. Okay, then again finally what would be the shift? Okay, what would be the shift? You take 3 minus n, or minus n plus 3 is equal to 0, and again n is equal to 3. Finally our diagram will be shifted towards right side. Okay, our diagram will be shifted towards right hand side. Okay, but and also with the effect of scaling, because with the effect of time reversal, because n is negative. Okay, so here time reversal is also there, and also shifting is also there, but finally the diagram will be shifted towards right side. Okay, right side. So now once if you are having this structure, okay, there are two ways we can go from this side to this side. First we can apply the time reversal, then shifting, or otherwise we can apply the shifting first, then time reversal. But once if it is in this structure, okay, then we have to apply the shifting first. Okay, so we'll calculate what is x of n, x of n plus 3, then later we'll calculate what is x of minus n plus 3. So this is x of n plus 3. Okay, so for a given x of n, first you calculate x of n plus 3. That means what? The diagram has to be shifted towards left side. This is actually the temporary operation, but finally the diagram will be shifted towards right side. But this is like a temporary operation. Now you shift the diagram towards left side by 3 unit. Okay, then once if you shift the diagram towards left side by 3 unit, then it will start at minus 7. Okay, then minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, and then 0. So this is minus 1, minus 2, and again this is plus 1 by 2, plus 1, plus 1, plus 1, plus 1, and plus 1 by 2. So what I have done, given the x of n, okay, given this x of n, you shift the diagram towards left side by 3 unit. Okay, this is like a temporary operation. Okay, so I have calculated what is x of n plus 3, but what I need x of minus n plus 3. Now for this diagram, you apply the time reversal. Okay, for this diagram, you apply the time reversal. Once if you apply the time reversal, means it's like time reversal means mirror image with respect to y-axis. Time reversal means mirror image with respect to y-axis. Then now what will happen once if you take the mirror image with respect to y-axis? Now again, if this is 0, okay, 1, 2, 3, 4, 5, okay, and then 6, 7. If you take the mirror image, okay, then it will be like this. Okay, this will come here, and again all these ones comes here. Okay, then next this 1 by 2 will come, and again this minus 1 by 2, and again this 1. Okay, so this diagram is the mirror image of this diagram. Okay, now ultimately we got x of minus n plus 3. So once if we compare this x of minus n plus 3 with x of n, again finally the shift will be towards right hand shift, because you see, you compare the original diagram. Okay, here it is starting with minus 4. I'm not worried about what is the amplitude and all now. This is starting at minus 4, but this is starting at 0. Finally shift is there. Finally it is shifted towards right hand side. Finally it is shifted towards right hand side. That we can calculate in the beginning itself. Finally this diagram would be shifted towards right hand side. Okay, that information we can get here, but then how to get the actual value? For that we have to do this intermediate step. Okay, because first we are doing the shifting, that is x of n plus 3, then we are applying the time reversal, then finally we are getting this. Okay, or otherwise you can apply the reversal first. Okay, so once if you take in this format, suppose x, you take the minus outside. Okay, if you do in this format, okay, you can apply the reversal first, later you can apply the shift. Okay, you can apply the reversal first, later you can apply the shift. Okay, in both the cases you'll get the same answer. In both the cases you will get the same answer. Okay, so next question. The next operation is x of n u of 3 minus n. Okay, already x of n we are having. We have to multiply with u of 3 minus n. So that means we should know what is u of 3 minus n. Okay, what is u of n? U of n is the discrete time signal which will have values only for positive values of n. Okay, 0, 1, 2, 3. It's like that up to infinite. This is your u of n. Okay, this is your u of n. Again, all the values are 1. Okay, 1, 1, 1, 1, 1. Now, what is u of minus n plus 3? Okay, So u of minus n plus 3 means, again, first you can calculate what is u of n plus 3. Okay, u of n plus 3. Okay, then once if you calculate u of n plus 3, then what is the shift? Shift, okay, n is equal to minus 3, then it will be uh, shifted towards left side. Okay, then once if you shift towards left side, then your diagram will start here. Okay, your diagram will start at minus 3, and then minus 1, 0, 1, 2, 3, like that it continues. Okay, so this is u of n plus 3. Okay, your u of n plus 3 means what? U of n shifted towards left by 3 units, shifted towards left by 3 units. How to identify that? Because n plus 3 is equal to 0, n is equal to minus 3. That means this diagram, original diagram, has to be shifted towards left by 3 unit. Okay, so now this is u of n plus 3. Then, but we need u of minus n plus 3. Okay, then that means what? We have to apply the time reversal for this diagram. If you apply the time reversal for this diagram, okay, so you'll get like this. Okay, it will come up to 3. Okay, this pattern will come here. Again, all this pattern will go to the negative side. Again, it will be extended to the minus infinity. Okay, then minus 1, minus 2, minus 3, like this. Okay, so now this is the final diagram for u of minus n plus 3. Okay, again, it is very simple. See, suppose u of minus n plus u of minus n plus 3 is given. Anyway, u of n will have constant amplitude, that is 1. Okay, as it is minus, okay, definitely as it is minus, okay, it will be having negative values. That's okay, negative values. Okay, the samples will be present at negative values. Okay, so what is the idea? The samples present at negative values, surely negative values. Again, once if the signal is having negative value, then that signal will go towards left side. Okay, the signal will go towards left side. Signal goes, because it is having negative time index, signal goes towards left side, but the thing here is where it is starting exactly, that we can easily identify. Minus n plus 3 is equal to 0, then n is equal to 3. Okay, there's some signal is starting at n is equal to 3, but it is going towards left. Okay, so that means what? Once if they given u of minus n plus 3, then directly you can identify the signal is starting at 3, time index 3, but it is going towards left. Okay, going towards left, then you can easily put the rest of the value up to minus infinite. Okay, you can put all the samples. This is minus 1, minus 2, again this is n. So the moment they give this u of minus n plus 3, then very easily you can put this function. Okay, it is the signal is going towards left, and also where it is starting, it is starting at n is equal to 3, but it is going towards left. Then this is the nature of the u of minus n plus 3. Now this u of minus n plus 3, okay, so how can you denote in mathematics? This u of minus n plus 3 is having the value 1 when n value is in between 3 to minus infinite, or otherwise when n value is in between minus infinity to plus 3, the value is 1 or 0, otherwise. Okay, in all other cases the value is 0. This is the mathematics. Okay, now again it's very simple, all the values are 1. Now you are having original signal. Okay, where original signal is going from minus 4 to 3, then only again once if you multiply with this one. Okay, see, what is the original signal? The x of n original signal is having time index. Time index is in between minus 4 to 3, in between, including minus 4 and 3. If you see the original signal, okay, the original signal is having time index in between minus 4 to 3. Okay, minus 4 to 3. Now this signal u of minus n plus 3 is having time index. Okay, it is having time index in between minus infinity to plus 3, minus infinity to plus 3. Again, if you compare this, this is having from minus 4 to 3, this is having from minus infinity to 3, again this will provide all are equal value 1. So once if you multiply these two, okay, so if you multiply x of n with u of minus n plus 3, okay, again definitely you will get x of n, there is no doubt, because whatever the samples that you need in between minus 4 to 3, it will provide the value of 1. Okay, for other values also it will provide 1, but this will provide 0, but no problem. But we need samples in between minus 4 to 3, that time it is providing 1. Then definitely once if you multiply x of n with the u of minus n plus 3, definitely you will get x of n. Okay, so again here the answer is very simple, the answer is x of n itself. Okay, again if the time index are a little bit different, then based on that you will get diagram that may not be equal to x of n with some, well, with some reduction in the samples you may get. Okay, with some reduction in the samples. Okay, so instead of u of minus n plus 3, suppose if they given u of minus n plus 1, again your n index value in between minus infinity to 1, then from the original signal, you will not get the samples at n is equal to 2, at n is equal to 3, then you will get the rest of the sample. You will get the rest of the sample. That is the idea. So you have to compare this time index. You have to compare this time index. So the next question is x of n minus 2 and del of n minus 2. Again, we know the nature of del n. Okay, whenever del n is given, okay, it will have a sample only at n is equal to 0. N is equal to 0, its value is 1. In all other cases, the value of del n is 0. Value of del n is 0. And again, once if it is shifted, okay, if del n minus 2, then what is the meaning of that one? Okay, that sample is present not at n is equal to 0, but it is present at n is equal to 2. At n is equal to 2, this value is 1. Now, you again, this is the value of del is equal to n minus 2. It means it will have sample only at n is equal to 2. Then you are multiplying with the x of n minus 2. Okay, you are multiplying with the x of n minus 2. Okay, then what will be the answer? X of n minus 2, you are multiplying with the del of n minus 2. Okay, so again, if you see, again, before going to this, suppose you take x of n, for example, if you take x of n, if you multiply with del of n minus 2, okay, then what would be the answer? The answer would be x of n value only at n is equal to 2. Because in x of n, you may have any number of sample, no problem. But this signal is having sample only at n is equal to 2. Okay, only at n is equal to 2, it is providing 1. Then again, finally, you will capture the sample that is present only at n is equal to 2. Only at n is equal to 2. So from the original signal, we will pick up the sample only at n is equal to 2. So x of 2 will be the answer. Suppose if the question is like this. But the question is somewhat like this, x of n minus 2 and del of n minus 2, no problem. Again, you write the signal x of n minus 2, then you put n is equal to 2. Okay, x of n minus 2. Again, in the shifted signal, you put n is equal to 2. Again, whatever the value is there in n is equal to 2, you will get that answer. Again, if you see, okay, if you see the original signal, okay, what is the original signal? Okay, this is the original signal. If you shift it by 2 amount, then this whatever the value present here, that will come here. Okay, then once if you observe at the value at this point, you will get this value only. Okay, because it is shifted by 2 unit. Once if you shift and observe, you will get this value only. So that value mathematically we can get directly. Okay, so mathematically you substitute n is equal to 2 here, you will get x of 0. So after shifting, if you observe at n is equal to 2, that value will be really what is the original value of x of 0. So for this, the answer is x of 0. Whatever the values that is present at n is equal to 0, that is the answer for this question. Okay, so next, 1 by 2 xn 1 by 2 minus 1 power n x of n. Again, whenever this kind of question is given, okay, so what is the question? X of n you have to divide by 2 separately, you take it separately. Again, similarly, again, after dividing by 2, you multiply with minus 1 power n. Minus 1 power n means when n is equal to 0, it will be 1. When n is equal to 1, you have to multiply with the 1. Okay, so alternatively you are multiplying with the plus 1 and minus 1, then that will provide some signal. Finally you have to add both the signal, or otherwise mathematically you can do some modification here. Okay, you take the x of n separately, then you'll get 1 by 2 plus 1 by 2 minus 1 power n. Okay, minus 1 power n. Now what happens when you substitute n is equal to 0? Say if it is n is equal to 0, what we are getting? Okay, I am concentrating on this one. Anyway, xn is there already. When n is equal to 0, this is like 1 by 2 plus 1 by 2, that is 1. When n is equal to 1, this will be 1 by 2, this will be minus 1 by 2, then answer is 0. When n is equal to 2, okay, when n is equal to 2, this will be 1 by 2 plus 1 by 2, then answer is 0. When n is equal to 3, this will be like 1 by 2 minus 1 by 2. When n is equal to 3, 1 by 2, then answer minus here is 0, but here it is 1. Okay, now what we are getting, the function, this function with respect to n, it is providing alternatively ones, zeros, one, zeros, like that. Okay, and similarly you have to apply for minus 1 also, because we are having values at minus also. See, what is happening at minus 1, when n is minus 1, okay, when n value is minus 1, what will be the answer? Okay, when n is minus 1, you will get 1 by 2 minus 1 by 2, again 0. When n is minus 2, again this is 1 by 2 plus 1 by 2, 1. When n is minus 3, 1 by 2 minus 1 by 2 is equal to 0. When n is minus 4, this is 1 by 2 plus 1 by 2 is equal to plus 1. That means what, alternatively we are getting 0, 1, 0, 1, like that. Okay, so I can write it here. The function of this value, that is 1 by 2 plus 1 by 2 minus 1 power n, how it is producing the values. Okay, so but we are interested in what is our original signal range. Our original signal range is from minus 4 to minus 4 to plus 3. Okay, so we'll write all here. Minus 3, minus 2, minus 1, 0, 1, 2, 1, 2, 3. Okay, this is our original signal range. Okay, when n is minus 4, we are getting the value 1, 0, 1, 0, 1, 0, 1, 0, like that. So that means what, originally we are having signal x of n. With that signal x of n, for this sample we are multiplying with 1, for this sample we are multiplying with 0. So finally from the original signal, okay, we will have samples only at minus 4, minus 2, 0, 2, like that. Okay, so remaining sample value is 0. So what is the sample present at minus 4? That is minus 1. Okay, again here it is 0. Now what is the sample present at minus 2? Okay, the sample present at minus 2 is plus 1 by 2. What is the sample at 0? That is plus 1. What is the sample? Okay, so this is at minus 4. Okay, so this is at minus 2. This is minus 2. And again, this is at 0. At 0, we are having plus 1. And again, 1, no sample. Again, in 2, we are having plus 1. Okay, so this is the final answer. Okay, because we have to multiply this with our original signal x of n. This is the value of this one. This is the final answer. Okay, so the next question, x of 3n plus 1. Okay, so here if you see in this problem, shifting is also there and also scaling is also there. Whenever you do the scaling in the discrete domain, you have to be a little bit careful, because if it is continuous domain, okay, if it is continuous domain, okay, whatever the thing is there, because it is really continuous. So say for example, suppose if some diagram is like this, say 1, 2, 3, suppose if I do the scaling by the factor of 2, then this will become 1 by 2 and 3 by 2, because this is allowed in the continuous domain. The continuous domain, any value is allowed. But whereas in discrete, I cannot do like that, because suppose in the discrete, if some value is there in 1 and 3, okay, then if I divide it by 2, okay, then 1 by 2, and then this, if I divide by 3, divide by 2, then this is 3 by 2, both are not valid. Suppose if I am having some sample at 4, if I divide that sample by 2, then that sample will come at 2. Okay, so that is valid. So after scaling, okay, the number has to be like a whole number. Okay, if it consists of fraction, then we have to neglect that sample. That is the idea here. So whenever you do the scaling in discrete domain, you have to be little bit careful. So again, the 3n plus 1 is equal to minus 4, because that is our starting value, because original signal is ranging from minus 4 to plus 3. Again, once if you compare with this, again we'll come to know what is the mapping. Then n value will be minus 5 by 4. Once if this is the case, n value will be minus 5 by 4. Again, this is not valid. Okay, similarly, you write 3n plus 1 is equal to minus 3, then n is equal to minus 4 by 3, not valid. 3n plus 1 is equal to minus 2, again that will be mapped to n is equal to minus 1. Okay, so this is valid. So whatever the values that is present at n is equal to minus 2 in the original diagram will be mapped to n is equal to minus 1 in the new diagram. N is equal to minus 1 in the new diagram. Again, 3n plus 1 is equal to minus 1, then n is equal to minus 2 by 3. 3n plus 1, 0 is equal to n is equal to minus 1 by 3. 3n plus 1, 1 is equal to n is equal to 0. Again, whatever the value that is present originally at n is equal to 1 will be mapped to n is equal to 0. Okay, so 3n plus 1, 2 is equal to n is equal to 1 by 3. 3n plus 1 equal to 3. Again, n is equal to 2 by 3. So only we are getting only 2 valid samples, remaining all are invalid samples. Okay, so we have to do this operation only. Okay, you identify what is the value at originally at n is equal to minus 2, then you map it to n is equal to minus 1. Similarly, what is the original value at n is equal to 0, then you map it to, similarly, what is the original value at n is equal to 1, you map it to n is equal to 0. So if you do the mapping, okay, then you will get at minus 1, you will get 1 by 2, then at 0, you'll get 1. Okay, so this is the answer for x of 3n plus 1. 3n plus 1. Okay, so then the next question, find x of n minus 1 whole square. Okay, so again, these are all some new operations. Okay, this will not come under the basic operation. Okay, whenever if they given like this, okay, then you just calculate what is again what the mapping we will do in general. Okay, so n minus 1, again we know the original range of the signal is from minus 4 to plus 3. Okay, the original range of the signal is from minus 4 to plus 3. Then you apply the mapping. Okay, n minus 1 whole square is equal to minus 4. Okay, and again similarly for minus 3, minus 2, minus 1, again you can apply for 0. Okay, again you can apply for 1. Okay, and also you can apply for 2, you can apply for 3. Okay, 3. Again, we know, again from this you cannot calculate the n, because this will become complex. Again, that is invalid. So again, up till minus 1, the n will be invalid, because n will become like a complex. Okay, again here, once if n minus 1 whole square is equal to 0, then it indicates that n minus 1 is equal to 0. Then here you will get n is equal to 0. So that means whatever the things that you are having originally at n is equal to 0 will be mapped to n is equal to 1 in the new diagram. Now, what will happen here? Again, n minus 1 whole square is equal to 1. Now here we are having some ambiguity here. See, n minus 1 whole square is equal to 1. When this is the case, n minus 1 can be plus or minus 1, because once if you take square root for 1, then n minus 1 could be plus or minus 1. Then n will be, n can be plus or minus 1 plus 1. So that means n can be 0, or n can be 0, or n can be 2. So here the tricky part here is, once if you do this mapping, okay, whatever the thing that is available originally at n is equal to 1 now will be mapped to n is equal to 0 as well as n is equal to 2. N is equal to 0 as well as n is equal to 2. And again here, if you take the square root again for 2, if you take square root again, that will not be a whole number. Again, n will not be a whole number. And this is also invalid. Like this is also invalid. So the 0 sample will be mapped to n is equal to 1 sample at the new diagram. Whereas this sample in the original diagram, when n is equal to 1, that sample will be mapped to n is equal to 0 as well as n is equal to 2. Okay, so once if you map that, okay, you'll get the diagram like this. Okay, what is originally available at n is equal to 0, n is equal to 0 originally available, that will be mapped to n is equal to 1. Okay, again, what is originally available at n is equal to 1, that will be mapped to n is equal to 0 as well as n is equal to 2. You know, this is the final answer for x of n minus 1 whole square, x of n minus 1 whole square. Okay. Next we'll see the another problem. Draw the rectangle t plus 1 by 4. Okay, we know how to operate with the general signal. Okay, but this is a special signal, rectangular signal. In that signal, they are applying the shift. Okay, whenever rectangular signal is given, they are giving this shift, how to operate. So this signal you can write like this. Okay, rectangle. Again, you can, this 4 is common to both t and 1, so this is 0.25 t plus 0.25, like this you can write. So again, once if it is given like this, okay, so whenever the rectangular signal is given, again we can write like this. Now here we have to understand one thing. In general, the rectangular signal itself will get, say for example, instead of rectangular t, say this may be the original rectangular signal. So in the original rectangular signal itself, okay, t is there along with the 4. Okay, so that means t is alone is not the time parameter. Okay, along with the 4, it is the time parameter. Okay, whatever there it is in the original signal within the bracket, then that is the time parameter. So here t alone is not a parameter. T by 4 is the parameter. So once if you think in that manner, okay, so this is like rectangular t, t alone is not time parameter, t by 4. Okay, this entire thing is the time parameter. If you imagine like that, okay, then this is shifted by 4 unit. Okay, this entire thing is the time parameter. Then this is shifted by 1 by 4 unit. Okay, towards left or right accordingly. Okay, so towards left or right. Okay, so now what is happening? See, once if you take t by 4 simply, okay, if you take t by 4, that t by 4 will vary, t by 4 will vary in between minus 2 to plus 2. Okay, t by 4 will vary in between minus 2 to plus 2. Then what will be the variation of t by 4 plus 1 by 4? Okay, you simply add 1 by 4 with this. Okay, so the original signal, okay, when it is a rectangular t by 4 is the original signal where the time varies from minus 2 to plus 2, because this width has to be equal to this value. So it will vary from -2 to +2. Again, in the new signal, this is the new signal, modified signal, t/4 plus 1/4. Again, if you equal with the original value that is -2, then in the new signal, you will get the value that is -2.25. Okay, this 2 will be mapped to, sorry, this -2 will be mapped to -2.25. And then similarly, this 2, once if we take these 2, and again, in the new signal, it will be mapped to 1.75. Okay, so -2 will be mapped to -2.25, plus 2 will be mapped to 1.75. Or otherwise, if you do it by other method, say this is the original signal, rectangular t/4 is the original signal, then this is the original time, t/4 is the original time, then you are applying some shifting, the shift is 1/4. So that means what, once if you equal to 0, then this t/4 will be shifted by, okay, is equal to 0, then t/4 is equal to -1/4. Again, this t/4, okay, this is like t/4, then this diagram will be shifted towards left by the unit of 0.25. Okay, so once if you shift this diagram towards left by the unit of 25, 0 point, that is minus 0 point, because it is minus, it is shifted towards left. Okay, so then minus 0.25, then this will be minus 2.25, and this will be 1.75. So this is the final answer. Okay, so it is not something equivalent with the regular method, because in the regular method, for any signal, the time axis will be t. But in a case of rectangular signal, the time axis is not only t and also with 4. Okay, so along with this, both the numerator and denominator represent the time axis. Okay, that's why we are doing in some different manner here for rectangular signal. Okay, so for rest of the signal, we will apply the ordinary procedure. Okay, thank you.